Hello everybody. For our final section here, we're going to talk about stream landforms. So this has a lot of information here on it, most of our major pieces for the section. So here is our meandering stream. We have oxbow lakes, we have little meander scars, similar in shape. You see the oxbow lake here, but a little bit less defined. We have our point bars, which we'll talk about in a bit. The cutoff, which separates the stream from the oxbow lakes, as well as these little natural levees here, and the big thing, the floodplain. So we cover this in detail, but just for a brief review, we have our stream here. We are eroding on the outside and depositing on the inside. And this right here, over time, as we erode more and more and more, eventually becomes a cutoff. We no longer use this entire long loop. Instead, we go straight down and have this sort of abandoned meander over here, which we call the oxbow lake. And this is a real example of this. You can see there's quite a few oxbow lakes and little relic old meanders that are present here all over the place. It tends to be much, much messier than what we see in our diagrams to look at a real example of this one. There's also this, which is a little bit of a cleaner example here. As you would imagine, location here starting to get very, very thin, starting to get eroded down. You might expect that this would become an oxbow lake in the future. So these natural levees. So we start out with our river here. We're going to imagine that it's brand new, nothing has ever happened here before. River's flowing, and then it floods. And as it floods, all the sediments in the river come up as part of it. The river is carrying some sort of sediment in it. And the very coarsest, largest stuff falls out right away. Falls out very, very quickly, does not travel very far here at the edges. And it slowly gets finer and thinner as you move away. You repeat this process many times with floods until you build up a natural levee, which stops any more floods from occurring. And you can see it a little bit here, right? You have this natural levee, which prevents flooding except in more extreme cases, huge precipitation events. And this diagram does have a lot of visual information to take in. Our river is flowing from top to bottom. Blue is the motion of the water, and the yellow here is the direction of channel migration. So what are we talking about here? So we're eroding on the outside, and some of the sediment makes its way down and back to the inside where we deposit. So over time, we would imagine that this whole thing, right, we erode over here and deposit over here, and there's this net motion of the river in this direction. We have the arrows, and the opposite on the other side here. And a real example, you can see it here. So there's this point bar on the inside of the river where sediment has built up, whereas erosion happens on the outside. The best way to remember this, the water is moving the most quickly as it moves around the outside. Right? It has to move even more quickly moving around the outside because it's moving a longer distance. Right? Water on the inside is moving the most slowly, so it is easiest there to have sediments which drop out of the water and build up into the point bars. See it here, a little bit of an example as well. So we're eroding on the outside, where the water moves the most quickly, and we're depositing on the inside, where the water moves the most slowly, and over time, here, the net direction that the stream is going to move in is this way, right, to the left, in terms of how it slowly moves over time. So here we're looking at a form called delta. So the Greek letter delta, if you've seen it, is just a triangle, right? These are, roughly speaking, sort of triangular bodies in shape. This one doesn't have the triangle shape in the most clear-cut way. Some of the later examples are a little better at this, but this is something, a landform which builds up where we have the stream hitting a larger body of water, like an ocean. And slowly it deposits more and more into the ocean, but its sediment load over time and slowly builds outward, as in famous cases here. you might take a moment, pause the video, and try to identify what it is that you're looking at here. Where is this? So this is the Mississippi River and the Mississippi River Delta system, collection of deltas here. Everything from the very earliest delta here, 400 to 600 years before present, all the way to the latest stuff, the most recent things over here, the Burfoot Delta. See, very clear there. And you can really track the evolution of the river by looking at the geology of the different landforms here, the different deltas. And eventually you build up a story for what has happened to this river system over time. This is another example of the delta here. You have a stream which meets a larger body of water, and it's the water moving relatively quickly through the stream, and then as soon as it hits that larger body, the energy of the stream dissipates, and all of the suspended particles, all of the particles of sediment which are in the river suddenly slow down really, really quickly as they hit this big, relatively slower moving body of water, and then as it slows down, the sediment tends to fall out. It slowly builds outward in the form of these deltas. And yes, I think it's this one you can really see why these are called deltas, because it starts to form these triangular shaped bodies. So what are our big ideas? So the first big idea you'll need to be aware of is the next two numbers in the access code are 6, 6. So first off, Earth's water, what is the breakdown of those percentages? Everything in that lecture is especially important. We talked about our different stream channel types, straight, meandering, and braided. What are the variables involved? What do these look like? What are the features? What are the major streams and surface waters in Arizona? How do these behave? Where do they go? And finally, our stream landforms in the final section. That's all for this unit. Next unit, we're going to talk about groundwater, everything going on below the surface.